All right, so this video is going to be over um, 10.5 and 10.6 for my Math 108, but it also is going to be covering log equations is the idea of this one. And so for the first little bit, just a couple things on how to put in a log basically in your calculator and the idea of a change of base. So first of all, if I have something, this is my first, I'm just going to give a couple examples. This is for 10.5, but there really isn't a whole lot to show because a lot of it's just on your calculator. So you put numbers in and you figure them out. So one thing I want to make sure you understand is if I have like log of 7 base 2, something like this, and you need to figure that out, you use what's called the change of base, which we've looked at a little bit, but not a lot. So what we do is we do the log of 7 over the log of 2. And we just enter that into our calculator. So I have just a scientific calculator here. And I have to put it to where um, the glare from my camera doesn't make it not show up. So what we do is we hit the log key, which here's the natural log, but here's the log key of 7 in your parenthesis divided by, excuse me, log of 2. If you didn't end your parenthesis on that, it wouldn't work. And so it's 2.81 if you round up. So this is about 2.81, right? And so you have to be able to convert those to basically whatever base you want. This is converting them to base 10 because you left off the base, right? So you're converting it and you could divide and get the answer. So that'll be helpful for some of those problems. And most of them in 10.5, you're just putting in your calculator and doing regular simplifications. What I really want to focus on is equations with logs. So logs are used to solve equations that have the x as the exponent. They're also you're given equations already with logs, and then there's two different versions of those. Let's start with if your exponent is an x. So what if I have 3 to the x equals 12? And this is actually where you will see the use of logs the most is to solve an equation with a variable in the exponent place. So what we do is we magically appear log on both sides because what you do to one side you do to the other. So I take the log of both sides. So on this side I get log of 3 to the x. On this side I get log of 12. Then from here, I know I could take down the exponent. Hence the reason why we like these. So this becomes x times the log of 3 equals log of 12. And then I can divide by the log of 3 and I will have my x. So I'll have log of 12 divided by log of 3. And I need to enter that into my calculator. Again, so I'm going to hit log, oh shoot, what is it, 12 divided by log of 3 in my parentheses, and I get about 2.26. So x is about 2.26. All right, so here's one. Let's look at one that has an e because you have to use the natural log for these ones. What if it's e to the power of, I don't know, 0.003x is equal to 40. So e to the 0.000x to the 40. So what I want to do if I have an e involved is I don't want to use regular log. I use natural log. So I'm going to put in the natural log of both sides. Again, x is in the exponent, so I'm putting in logs to solve. So it's going to become natural log of e to the 0.003x equals natural log of 40. Okay, and same idea. You bring this back down and I get 0.003x times the natural log of e equals natural log of 40. What is the natural log of e? Well, it's like a natural log is log base e. So e to what power is e? It's 1. So natural log of e is just 1. Well, 1 times this is going to give you 0.003. So times the 1. I'm gonna move a couple things out of my way here to be able to move my paper up a little bit. Then, so I really just have this. We know natural log of 40 is just a number, so I got to put that in my calculator, and it is an L. When you type into MyMathLab, a lot of people use a 1, and it is not a 1. It's a log, L. So natural log of, oh goodness, what was it again? 40. Okay, so that's 3.69. That's going to be our number here. So I have 0.003x equals 3.69. Divide that by 0.003 and I get an answer of 1,229.63. Okay, so there again is another one where the x is in the exponent and you have to bring in a log, but you have an e, so you want to bring in a natural log instead of a log so that, I mean, you could actually solve it with a regular log, but e's hard because it's some of the calculators don't have that key. Usually they just have e to the x, which you can use to the power of 1, but if you use natural log of e, it becomes 1, so that's why we want to use that. Okay, so let's try a couple more that start to look a little bit different. Okay, what if... Okay, so also, like the two problems we just got, you might get an interest problem on those. Um, and it's the same thing, but it's just a formula for calculating how much interest you might gain on a credit card, or sorry, not gain, have to pay, or interest you gain in an account. So you might see some things on that. Let's look at, this is my fourth example. Let's look at one that comes with a log in it. Okay, so I know that you can solve the problems with an x in the exponent place, whether it is a formula they give you that you fill out or not. So let's start looking at the other two types that we'll see. One is where you have one log in the problem. If you have one log, you want to change it to exponent form and then solve it that way. And then the last method that we're going to learn is if it comes with two logs. So let's look at converting this. You take this, the base of the log to the power of what you equals will equal this. So we'll go 2 to the 4th is going to equal x plus 5 to the 3rd. And that's how I convert to exponent form. 2 to the 4th is just 16. And then how do I get rid of a third power? Well, I take the third root. So let's do that. We take the third root of x plus 5 to the 3rd. And if we do it on that side, we have to do it on this side. So we take 16, third root of 16. So we're going to kind of go that way. Okay, then let's figure these out. So third root, this is going to end up just being x plus 5 over here because third root of a third power is x plus 5, or whatever the base part was, which is why we do that. But then over here, we have to look at the third root of 16. Can you take the third root of 16 without getting a decimal? Because sometimes they want you to have a decimal, and sometimes they don't. If you look, I'm going to take the third root, which I have a key for where I have to tell it 3. Oops. Maybe if you can see it there. 3, and that tells it to the third root of 16. And let's see if we can get, if we don't get a decimal. Nope. There's nothing to the third power that equals 16. If it was a second power, right, if we were square rooting and not third rooting, then that would work. But 16 does not have a third. So let's leave it in the exponent form, or a radical form for this one, and we'll minus the 5 over. So one answer minus the 5. Make sure the 5 is written outside of your radical because this is a number here. Now I could take the number I have and minus 5 and get the about answer, right? So x is about negative 2.48. So it depends on if it's a word problem or it depends on the direction. So a lot of times you want to leave it in this form. Sometimes you want the decimal. So it kind of depends. But there is the solution to that one. What if I have, or I start with 2 logs already? These are actually the easiest ones that we're doing. That's a 4. I didn't write that 4 super well. So I've started with an exponent of an x. I've then moved to 1 log, and now I've moved to 2 logs. Or I could have like 3 logs. If you have more than 1 log, the goal is to get 1 log on each side, and then basically, this is the same thing. You lose the log. Just like I entered the log on the other problems, I can take them out as well. So I'm going to take them out, and that would leave me 5x minus 2 equals 4. You solve that equation, and you get x equals 6/5. So pretty easy equation. I add the 2 over, divide by 5. So that's one type. What if it was written like this one? What if I have log of 5x minus log of 2x minus 1 equals log of 4? Okay, so I've log of 5x minus log of 2x minus 1 equals log of 4. Well, I can't do anything when I have 3 logs like this, okay? Because minus in logs means division. So we got to combine these to where you have 1 log on each side. So this side becomes log of 5x over 2x minus 1 equals log of 4. Now the rule applies that I can take the logs out, now that I have 1 log on both sides. So I'm really left with 5x over 2x minus 1 equals 4. And then I solve this equation. So this, you could think of this as a proportion. Gosh, I couldn't even think of the name. Think of this as 4 over 1 and then cross multiply. So I'd take the 2x minus 1 times 4. And 1 times 5x on the other side would just be 5x. And then we can solve from here. So 4 times 2x is 8x. 4 times 1 is 4 equals 5x. So I'm going to move this x over this way, because if I move this one this way, then I have to move the 4. And a little bit easier if I just move the 8x over to combine the x's together, so that I have negative 4 because those go to 0. 5 minus 8 is negative 3x. Divide by negative 3, and I get positive 4/3 because that double negative becomes a positive. And that's my final answer on that one. Couple things you got to remember. There are some equations with no solution. You cannot have log of 0. Remember, that's undefined, because it's like saying 10 to what power equals 0. Well, 10 to the 0 is 1. You can't get 0. So no log of 0 is allowed. And I think those are the only examples I'm going to give you, because the rest of them, I mean, that is an example of every type of log equation that you might see. So I think I'll stop there.